understanding the exponent rules. In this presentation, we're going to seek to understand the following rules of exponents: the zero exponent rule, the product rule, the quotient rule, and the power rule. The zero exponent rule. This is b to the power of 0 equals 1, which means that any base b raised to the power of 0 is equal to 1. For example, 100 to the power of 0 equals 1. Any number, any base to the power of 0 equals 1. Why is that? Well, let's look at what happens when we take 100 to the power of 4, for example. Let's list all the factors. Well, 1 is always a factor because 1 is the identity for multiplication. And the 4 means that 100 is a repeated factor 4 times, that the base 100 is a repeated factor 4 times. So we have 1 times 100 times 100 times 100 times 100. Similarly, 100 to the power of 3 is 1 times 100 times 100 times 100. So 100 is a repeated factor 3 times. 100 to the power of 2, 1 times 100 times 100. 100 to the power of 1, here we just have 100 as a factor once. It's 1 times 100. Now, what about when we have 100 to the power of 0? Well, if the exponent tells us how many times the base is a repeated factor, this means that we do not have any 100s as a factor. But that still leaves us with that factor of 1. So 100 to the power of 0 is 1. It completes this pattern that you see here. And this same pattern would occur no matter what our base would be. This is why we know that any base to the power of 0 is equal to 1. And this is the zero exponent rule. The product rule. The product rule says that any base b to the power of m, so any exponent, times any base b to the power of n is equal to the base b to the power of m times n. Now note, there are a few conditions on all of these exponent rules. The base must be a real number as opposed to an imaginary number, and the exponents are positive integers. So for example, we could have our base b as 3, and our m as 3, and our n as 4. So we would have 3 to the power of 3 times 3 to the power of 4, and that is equal to 3 to the power of 3 plus 4. 3 plus 4 is 7, so 3 to the power of 3 to 3 to the power of 4 simplifies to 3 to the power of 7. Well, how do we know that it simplifies to 3 to the power of 7? How do we know that we just add the exponents? Well, let's do it all out as if we didn't know that exponent rule. 3 to the power of 3 we would write as 3 times 3 times 3, with 3 as a repeated factor 3 times. 3 to the power of 4 is 3 times 3 times 3 times 3. And we're multiplying the 3 to the 3 times the 3 to the 4. So if we wanted to simplify, to rewrite 3 times 3 times 3 times 3 times 3 times 3 times 3 using an exponent, we would write it as 3 to the power of 7. But if you look at carefully what we did, we added the 3 threes that make up 3 to the power of 3 to the 4 threes that make up 3 to the power of 4. So that gave us the total number of factors, which is indicated by the exponent 7. So that's why the product rule works. That's why when we multiply like bases that are real numbers, we simply need to add the exponents as long as the exponents are positive integers. The quotient rule. The quotient rule says that with the same conditions as the product rule, where the base is a real number and the exponents are positive integers, if the bases are the same and they're dividing, we can simply subtract the exponents. So b to the power of m divided by b to the power of n is equal to b to the power of m minus n. For example, 4 to the power of 5 divided by 4 to the power of 3 is 4 to the power of 5 minus 3, which is 5 minus 3 is 2. So the simplified version is 4 to the power of 2, which is 16. But you see here that with the quotient rule, we subtract the exponents. Why is that again? Well, if we wrote out 4 to the power of 5, where 4 is a repeated factor 5 times, we would have 4 times 4 times 4 times 4 times 4. And 4 to the power of 3 is 4 times 4 times 4. Now, if we wanted to simplify that expression, we would eliminate all of the 4's over 4's, because 4 over 4, anything over itself is 1, and 1 is an identity for multiplication, so we don't need to write it. 1 times anything doesn't change that number. So we scratch out all of the 4's over 4's. And then let's look at what we did. We took away the number of 4's in the denominator from the number of 4's in the numerator. So we went the number of 4's, which is the exponent of the numerator, minus the number of 4's in the denominator, shown by the exponent of the denominator. And that gave us 2. We have 2 4's left here. So 4 to the power of 2. And that is the quotient rule. When you have like bases and they're dividing, you simply need to subtract the exponents. The power rule. The power rule says that when we have some base to some power raised to another power, we multiply the two exponents. So b to the power of m to the power of n is b to the power of m times n. For example, 2 to the power of 3 to the power of 4 is 2 to the power of 3 times 4, which is 2 to the power of 12. Looking at why that works, we have 2 to the power of 3. That is 2 times 2 times 2. But that 2 times 2 times 2 is itself raised to the power of 4. So it becomes the repeated factor now, and it is repeated 4 times. So you see there we have 4 sets of 3 2's, each with 3 2's. And that is 2 to the power of 12. So that is why with a power rule we multiply the exponents. Here's a second example of the power rule. Suppose you have factors within parentheses raised to another power. So each of those factors in parentheses has a power already, but then it's raised outside the parentheses to a second power. So the 1 on the 1/3 has a power of 1. It is multiplied by 2. The 3 has a power of 1. That 1 is multiplied by 2. The m has a power of 1. That 1 is multiplied by 2. And finally, the 3 on the n is multiplied by 2, which simplifies to 1 over 3 squared, m squared, n to the power of 6, which is simplified as 1 over 9 m squared n to the 6th. And that's as simple as it can go. So that's the final answer. And a third example of the power rule. Suppose you have factors. We have factors here in our numerator being divided by another base to some power. So we have a quotient here within parentheses, and it's being raised to a second power. So we multiply that 5 outside parentheses by each of the powers on all of the factors you see here. And remember, if you don't see a power on a number, assume that power is 1. So we get 2 to the power of 5, a to the power of 4 times 5, b to the power of 3 times 5, and 2 to the 5th is 32, a to the 20th, b to the 15th. And that's our simplified answer. To summarize the rules, the zero exponent rule says any base raised to the power of 0 is 1. The product rule says that whenever you multiply like bases, you add the exponents. The quotient rule says whenever you divide like bases, you subtract the exponents. And finally, the power rule says when you have a power to a power, you multiply the exponents. And remember, the base should be real, should be a real number, and the exponents should be positive integers.